All right, so we're going to continue with multi-step equations. What is the difference between this problem and the warm-up problems posed? Well, unless you have the warm-up problem in front of you, you can't really tell. But the main difference is that you have two x's on the left-hand side. There are more than one variable, and a lot of the problems that we've been dealing with only had one variable in the problem, in the equation, and we just tried to get it by itself. So what do you do when there's more than one variable? Well, the same rules apply as it did yesterday and the days before. First, you're going to simplify each side as much as you can by combining like terms and the distributive property wherever necessary. Now, from the warm-up today, we did in class, remember like terms have to have the same variables exactly and same exponents with those variables. So for instance, let's just look really quick since you don't have the warm-up right here. Like terms would be something like 2x and 4x. Notice that they both have an x variable. Unlike terms, excuse my writing here, just trying to write quickly, would be something like 2x and 4y. Well, this is a x and this is a y, so they're not like terms. Now, I could have something like 3ab and negative 7ab. Notice they have exactly the same variables. I could have 3ab negative 7ab squared, and they are now unlike. They are unlike because of that square. Not only do the variables have to be exactly the same, they have to have the exact same exponents. So for instance, let's say I have 1/2 x squared y cubed. It would be a like term with negative 2/3 x squared y cubed. Or I could have 2/3 a squared b cubed, and even 2/3, even if the number's the same, that coefficient, they are not like terms if the exponents are not the same. So because the exponents on the a and b terms are different, they are not the same. So this side had an a squared, this has an a cubed, this side had a b cubed, and this has a b squared. Well, what if it was even closer? What if it was a squared and a b cubed, a cubed and a b cubed? Well, this 3, because it's not the same as that 2, still causes those to be unlike terms. So that's what it means to be like and unlike terms. All right, so now back here. So here's the first example. So when you're going to solve multi-step equations that have more than one variable or like terms that can be put together, the first thing that you do is you simplify each side as much as I can. So here's my equal sign, and I'm going to look at the left-hand side and see if there are any like terms. Well, I have an x and a 2x. Well, both of those are positive, so I want to put them together. So remember, if there's a variable and it doesn't have a number in front, it's like a 1. So 1x, a positive 1x, and a positive 2x combine to give me a positive 3x. And I did not do anything with it, so I'm going to bring down this minus 4. Notice actually it says plus negative 4. We do not need to double signs. Okay, if you have a negative in front of a number, that's like saying subtraction. So it's 3x minus 4 equals 14. So now you see it's back to much simpler looking problem. So now I have 3 times x minus 4. I want to get x by itself. We do reverse order of operations. So I add 4x to both sides. So that gives me 3x equals 18. So 3 times x, the opposite of multiplication is division. So x equals 6. And then I go to check my answer. So I'm going to say to check it, instead of x, it's going to be 6 plus negative 4 plus 2 times x. Instead of x, it's 2 times 6 equals 14. And then looking at it, remember order of operations, so we do the multiplication first. 2 times 6 is 12 equals 14. Always remember when you have double signs in a problem, like right here, Remember, plus a negative is the same thing as subtraction. So this is like 6 minus 4 plus 12 equals 14. And now we have all addition or subtraction, so we go left to right. So 6 minus 4 is 2. Bring down to plus 12. 2 plus 2 is 14. 14 equals 14. So that is correct. So that means my answer was x equals 6. Okay, looking at the next problem, I look at the left-hand side and it is simple as it gets, but when we look at the right-hand side, we have parentheses with an operation going on inside of them, so that means I can use distributive property. So 8 equals 4 times q is 4q. 4 times a negative 2 is negative 8, so we say minus 8, bring down to plus 4. Now looking at the equation, again, the left-hand side's fine, but the right-hand side, I have some like terms I can put together. I can put this negative 4, this negative 8 and this positive 4 together. So I bring down the 4q, and a negative 8 and a positive 4 gives me a negative 4. So I say minus 4. Now the right-hand side is as simple as it gets. And I want to move everything away from the q, so it's 4 times q minus 4. So I move that minus 4 first. Minus 4, to move it to the opposite side, I have to do the opposite, so I add 4 to both sides. And then when I add 8 plus 4, it gives me 12 equals 4q. And then that's 4 times q. So to undo multiplication, we divide both sides by 4. So q equals 3 is what I think my answer is, but I'm going to check it. So then I come here, and everywhere I see a q, I put a 3. All right, and then in the parentheses, I have 3 minus 2, which is 1. And then I have multiplication. 4 times 1 is 4 plus 4. 4 plus 4 is 8. 8 does equal 8, so that means q does equal 3. That is my correct answer. Okay, we just went over that. All right, so now here's a couple you were supposed to try. So starting off, left-hand side is as simple as it gets, but on the right-hand side I can distribute. 6 times negative 5m is negative 30m. 6 times 8 is positive 48. Bring down to plus 3m. Looking at that right-hand side, I have like terms of negative 30m and a positive 3m. So bring down to 21. Negative 30m and a positive 3m, when I combine that, that gives me a negative 27m. Then bring down that 48. And then in looking here, the right-hand side is now as simple as it gets. There's no more like terms. So then I need to move everything away from the m. I have negative 27 times the m and 48 plus being added to the m. So I need to move the addition first. So I subtract it from both sides. Cancels out on the right-hand side. And I bring down that negative 27m. And then I'm going to say 21 minus 48, and that's going to give me a negative 27. And then you notice I have a negative 27m on this side. It's negative 27 times m, opposite of multiplication is division, and I want to get rid of the negative and the 27. So I'm going to divide both sides by negative 27. Over here it cancels, and negative 27 divided by negative 27 is positive 1. So I think that's my answer. So to check my answer, I'm going to plug in. So 21 equals 6 times negative 5. Instead of 5 times m, it's going to be times 1. Plus 8 plus 3. Instead of times m, it's going to be times 1. So then it's going to be 21. Follow order of operations. I got to do what's in parentheses first. So negative 5 times 1 is negative 5. Plus 3 times 1. So 21 equals 6 times, inside parentheses, we got to do that first, times 3, plus 3 times 1. So then 21, order of operations says you do multiplication from left to right. So 18 plus 3 times 1. So 21 equals 18 plus 3. That was the last multiplication. And now 21 equals 18 plus 3, which is 21. 21 does equal 21. So that means my answer is m equals 1. Okay? So then the next problem, if I look at the left-hand side, it is not as simple as it gets because I have a 9r and a negative 6r that can go together. So if I have a positive 9r and a negative 6r, 9, positive 9 and negative 6 gives me positive 3. So I have a positive 3r from those two. And then I bring down that minus 8 equals negative 2. Now the left-hand side is as simple as it gets. The right-hand side is as simple as it gets. I have a 3 times the r and a 8 being subtracted from the r. So remember, we get rid of addition or subtraction first. Since I'm subtracting 8, to move it I need to add it. What I do to one side I have to do to the other. So bring down the 3r, cancel out the 8's, and negative 2 and positive 8 give me 6. Then it's 3 times r, so to move multiplication I have to divide. So this is going to be r equals 2. Well, I think that's what my answer is, so to be sure, I go back to the original. So instead of 9 times r, I'm going to say 9 times 2 minus 8 minus, instead of 6 times r, it's going to be 6 times 2. And we're going to see if that will balance out and all equal negative 2. So 9 times 2 is 18 minus 8. 6 times 2 is 12. And then 18 minus 8 is 10 minus 12. And then 10 minus 12 is negative 2. Negative 2 does equal negative 2, so therefore r equals 2 is my answer. All right, so looking at this next example, the main thing that I'll put this here for to point out is that notice it says 4m minus, and then there's parentheses. Well, what I want you to realize and recall is that whenever you have a variable or a grouping symbol and there's nothing beside it, you can always assume that there is a 1 because there's an imaginary 1 there. So this is like 4m minus 1 times parentheses 1 plus m. So I'm going to rewrite it to make it look a little bit better. Okay, so now that we have realized that, what you must focus on is when you go to use the distributive property, you're not just distributing 1, you're distributing a negative 1. Okay, not just a 1, but a negative 1. In the previous problems that we did, when we distributed, it was a positive number we were distributing. So we didn't stress over the signs. Okay? Here, when there is a minus, you must distribute that minus with whatever the number is. So this is going to be 4m, and then I'm going to say negative 1 times 1 is negative 1. Negative 1 times m is negative m, which we will write down as minus m, equals negative 1. Okay? Now we're going to put together like terms. So I have a positive 4m and a negative m. Remember, that's like negative 1m. So if I have a positive 4 and a negative 1, that's going to give me a positive 3m. Bring down the minus 1 equals negative 1. Now I have multiplication and subtraction. So I add the 1 to both sides to move it away. So I get 3m, and this cancels, equals, well, negative 1 and positive 1 is 0. It is okay to have a 0. All right? Don't stop there and think you must have done something wrong. Doesn't mean you did something wrong. It is okay. So then I have 3m, 3 times m equals 0. Opposite of multiplication is division. So m equals 0 divided by 3 is 0. So I think my answer is 0. So I'm going to come, and everywhere in the original problem I see m, I'm going to put a 0. And check my answer. So 4 times 0, and we need to simplify in parentheses, so we're going to minus a 1. 4 times 0 is 0, minus 1, and 0 minus 1 is negative 1. Negative 1 does equal negative 1, so m does equal 0. And the problem to the left, looking at the left-hand side, notice that we have some distribution that needs to go on. And notice that it's a negative 4, not a plus 4, so I have to distribute negative 4. So I bring down the 6 in. Negative 4 times 1 is negative 4, so we say minus 4. Negative 4 times negative 7, notice you have two negatives, so we say positive 28n and equals 64. So negative 4 times 1 is negative 4. Negative 4 times negative 7 is positive 28. Now looking at the left-hand side, I have two n's that I need to put together. They're both positive, so 28 plus 6, we add those together. Get 34n, bring down the minus 4, equals 64. And now I have multiplication and subtraction. So to move the subtraction first, we do the opposite to both sides. And then 34 times n, so we do division to undo it. So n equals 2, or at least I think that's what my answer is. So to check my answer, I go back to the original problem, and everywhere I see an n, I put a 2, and see if that left-hand side will equal 64 like the right-hand side will. Alright, so first things first, I got to do what's in parentheses. So we know 7 times 2 is 14. So it's going to be 1 minus 14, which gives me negative 13. And then I have 6 times 2 is 12, minus 4 times negative 13. And then I'm going to have 12 plus 52, because a negative 4 and a negative 13, when you multiply them, negative and negative is a positive. And then a positive 12 and a positive 52 does give me 64. So 64 does equal 64, so n does equal 2. Alright, and sometimes there's variables on both sides of the equation. Well, if there are variables on both sides of the equation, just simplify both sides, like normal, as much as you can, and then move the smallest variable to the opposite side. Okay, so let's look at an example. So looking at the first problem. Oops. Left-hand side is as simple as it gets. But on the right-hand side, I have a 6v and a negative 1v. Well, a positive 6 and a negative 1 gives me a positive 5v, and then bring down the plus 5. All right, so now notice I have a negative 5v on the left and a positive 5v on the right. And I want to try to simplify these. So I'm going to move the smallest variable to the other. So negative 5 and positive 5, which is smaller? Negative 5 is smaller, isn't it? So I'm going to move it to the other side. Still have to follow the rule. Since it's a negative, that means I have to add it. What I do to one side, I have to do to the other. So a negative and a positive cancels out and gives me 0. But on the right-hand side, a positive 5 and a positive 5 give me a positive 10. Bring down the plus 5. Okay? So it looks funny, but remember, it's okay to have a 0 by itself. Now I need to move away from the v. Now I only have one v. That's what I wanted. So I have 10 times v and v plus 5. So I want to move the plus 5. So to move it to the other side, I have to subtract. So I have negative 5 equals 10v. And then I have 10 times v. So we divide. So we have a negative 5 over 10 equals v. And if you recall how to simplify fractions, negative 5 or 5 over 10 simplifies to be 1/2. So v equals negative 1/2, or at least I think that's what my answer is. So I'm going to come to the side, and then everywhere I see a v, I put a 1/2. Now this one is a little bit trickier to check, but let's keep going. Oh, and let's not forget that negative. Okay, so remember negative 5 is like it's over 1, and so this would be negative 5 times negative 1, because remember when you multiply you go straight across, so negative 5 times negative 1 is positive 5, and 1 times 2 is 2, so I have 5 over 2 on the left hand side. Now here 6 is like over 1, and I'll have 6 times negative 1, which is negative 6, and I have 1 times 2, which is 2, plus bring down the 5, and then I have negative 1 over 1, and negative 1 times negative 1 is positive 1, and 1 times 2 is 2. So let's clean that up just a little bit here. Oh, not that far. Okay. And then I'm going to put those two fractions close together. And when I put them together, it gives me, because remember when you have the same denominator, you add straight across. So negative 6 plus 1 is negative 5 over 2, and then plus 5. So these two here give me negative 5 over 2. And remember, if I want to, I can change that 5 into a fraction that has a denominator of 2. Because remember, 5 is like over 1. If I wanted it to have a denominator of 2, I'd have to multiply the bottom by 2. If I do that to the bottom, I have to do the top by 2. So this would be 10 over 2. So now they have the same denominator. So then I would say negative 5 and 10 give me positive 5, and it's over 2. So 5 over 2 does equal 5 over 2. So this is the answer. Now, if you were checking this and you are not extremely familiar with fractions or don't trust yourself, it would not be a bad idea to change negative 1/2 into a decimal and use your calculator to check it. Okay, but that is how you do it by hand in case you were wondering. All right, so now the next problem, and I'm going to need to make me some room here. Maybe. There we go. All right, and before we do this, again, I don't want you to stress over having to check that problem because it did have fractions, and I'm not going to require you to check something like that by hand. Okay? You may be required to check some of your answers on a test or on a quiz, but I will not give you one that hard and expect you to do it by hand. I would suggest you learn how to do it by the calculator, at least as a good check, and it's not bad to learn how to do it, but I will not require you to do it by hand, not at this point in algebra. Okay? All right, so moving on. Looking at the next problem, I have actually 3 n's. So let's focus on the left-hand side first. On just the left-hand side, I have a negative 5n and a positive 8n. So I want to put those together. So that would become a 3n and bring down to plus 1. On the left-hand side, it's actually as simple as it gets already. So I just bring it down. And now I have n's on both sides, so which is smaller, positive 3n or positive 6n? Well, hopefully you see that the 3n is smaller, so it's positive, so to move it to the other side, I subtract it, bring down the 1, get 3n plus 4. Now somebody may be wondering, well, could I have moved the 6? Yes, you could have, and it would give you the same answer, okay? And I will not count it wrong, depending on which way you move it. I just like being able to give a set of rules that at least somebody can follow and be consistent with if they really, really, really like rules. So you could move the 6 in first. You could move the constant 1, the plus 1, or you could move the plus 4. That's the cool thing about algebra. You can move whichever you want to first as long as you follow the rules, as long as you do the opposite and do it to both sides. Okay, so I have 1 equals 3 times n plus 4. So we're just back to now 2 steps. I need to move the plus 4 first, or next, I should say. So 1 minus 4 gives me negative 3. Bring down the 3 in. This cancels. And then 3 times n, so to undo the multiplication, I divide. Notice I don't divide by negative 3. I don't divide by negative because I'm just moving this positive 3, so I divide by positive 3. Negative 3 divided by 3 is negative 1. These 3's cancel, so n equals negative 1 is what I think my answer is. So I'm going to check it. Thankfully, this one should be a lot nicer than the last problem. So let's plug in. Everywhere I see an n, I put a -1. And this is why I loved algebra, because I could always check my answers. So then I just go through -5 times -1 is 5. 8 times -1 is -8. Notice that gives me a double sign, doesn't it? Plus a negative, remember, is the same thing as minus. Bring down that plus 1 equals 6 times -1 is -6. Bring down the plus 4. 5 minus 8 is -3 plus 1. -6 plus 4 is -2. And then -3 plus 1 is -2. -2 does equal -2. That means n equals -1 is my answer. Okay? All right, so then here were a few I wanted you to try. I really gave you some long equations because I think you can do it, and just because it's good to stretch your brain sometimes. All right, so looking at the left-hand side, I do have some like terms. I have a -3 and an 8 that both have a's, so I put them together, and that gives me 5a. Bring down the plus 11. And on the right-hand side, I have a positive 1a, a positive 1a. So I bring down the 8, put the a's together, and get 2a. That makes that long-looking equation a whole lot shorter. Okay, so now I have a 5a and a 2a, so I want to get them together. The 2 is smaller, so I'm going to, instead of add 2a, to move it to the other side, we subtract. And notice I only put it with another a. I don't go put it with the 11 because remember they're not like terms. So they cancel out here. This gives me 3a plus 11 equals 8. So now it's a lot nicer looking now. So now I just have 3a, which is really nice. I need to move the 11, so I'm minus 11. Bring down the 3a, the 11's cancel, gives me a -3, so it's 3 times a. So to move it, I got to divide, so a equals -1. That's what I think my answer is. So to double check it, I'm going to plug it in. So it's going to be -3 times -1 plus 8 times -1 plus 11 equals 8 plus a -1 is the same thing as -1 plus a -1 is the same thing as -1. So then this would be a positive 3 minus 8 plus 11 equals 8 minus 1 is 7, minus 1 is 6. And then we say 3 minus 8, which is -5, plus 11 equals 6. 6 does equal 6, so that is my answer. All right, and then let's look at this problem. I have lots of like terms. Look at the left-hand side. I have a 6 that can go with the 2, and I have a positive 3r that can go with the -2r. So let's put those together. So a 6 positive and a positive 6, a positive 2 give me a positive 8. And then I have a positive 3 and a -2, so that gives me a positive 1r. So that was the left-hand side. Now let's look at the right-hand side. On the right-hand side, I have a positive 7r and a -4r. So 7 and -4 gives me a positive 3r, and I bring down that -4. Now that looks a lot nicer. So now I'm going to move the smallest variable to the biggest. Well, the smallest is a plus 1r, so I subtract it from both sides, bring down the 8, cancels here, gives me a 2r minus 4. Now I just have multiplication and subtraction. So I get rid of the subtraction first by adding it. So I get 12 equals 2r. And then it's just multiplication, which we know the opposite of is division. So r equals 6. I think that's my answer, so I'm going to plug in and check. So I will say 6 plus 3 times 6 plus 2 minus 2 times 6 equals 7 times 6 minus 4 times 6. Wow, about ran out of room there. Okay, so going from left, I got 6 plus 18 plus 2 minus 12 equals 42 minus 4 minus 24. Now I have lots of addition and subtraction. So 6 plus 18 is 24, plus 2 minus 12. 42 minus 4 is 38, minus 24. And then I have 24 plus 2 is 28. Oh no, that's not right. 24 plus 2 is 26, minus 12. And 38 minus 24 is 14. And 26 minus 12 is 14. 14 does equal 14, so 6 does equal R. Okay? And then let's look here. I'm just making it more challenging and more challenging. Because if you can do these, you are awesome. And I believe every one of you are awesome. Okay, so looking at this problem, I have negative 30 plus 8x equals x. Got to get rid of the distribution first. Remember, we're distributing a negative 2. So negative 2 times 7 is negative 14x. Negative 2 times negative 6 is positive 12. And now look at the left-hand side. It's as simple as it gets, but on the right-hand side, I have like terms. I have a positive 1x and a negative 14x. So I'm going to bring down just what's on the left-hand side and work on the right-hand side. So a positive 1 and a negative 14 is a negative 13x plus 12. Now, be careful here. Left-hand side is as simple as it gets. Right-hand side is as simple as it gets. But now I'm trying to solve for the variable. Which one of the variables do I move? Do I move the positive 8 or the negative 13? Which is smaller? Hopefully you realize negative 13 is smaller. So to move the negative 13, I'm going to add it, because remember, negatives become positive when we move them over. So bring down the negative 30. 8x plus 13x is 21x equals, those cancel, and it leaves me with 12. Now I have a negative 30 plus 21 times x. So remember, we get rid of the addition or subtraction first. Well, we have that negative 30, so to move it, we add it. I don't know what's going on there. So it cancels, bring down the 21x. This gives me 42. And then it's just 21 times x equals 42. We know the opposite of multiplication is division, so x equals 2. I think that's my answer. So I am going to plug in and check. So I got negative 30 plus 8 times 2 equals 2 minus 2 times the quantity 7 times 2 minus 6. So in looking at this, I have negative 30 plus 16 equals 2 minus 2 times, well, I know that 7 times 2 is 14, right? So I'm going to have 14 minus 6, and that is 8, okay? And then on the left-hand side, I have a negative 30 and 16, and a negative 30 and 16 is going to give me a negative 14, and I have 2 minus 2 times 8. Well, 2 times 8 is 16. 2 minus 16 does give me negative 14. Negative 14 does equal negative 14, so that is my answer. All right. Looking at this problem, I have negative 21 minus n on the left side. That's all good, as simple as it gets, but I need to distribute this 7. So negative 21 minus n, 7 times negative 3 is negative 21. 7 times negative 5 is negative 35, so we do minus 35n. Now the left-hand side is as simple as it gets. The right-hand side is as simple as it gets. Here's my equal sign. So I want to move the smallest variable to the other. Well, I have a negative 1n. Remember, if there's not a number there, it's like a 1. And I have a negative 35n. What is smaller? What is less? Negative 35 or negative 1? Hopefully you realize that negative 35 is less. So to move it to the other side, I'm going to add it to both sides. Bring down the negative 21. This is going to give me positive 34n Bring down the negative 21, and it cancels there. Okay? Now I have one variable n. I need to move the 21 to the other side. So it's a negative, this 21 to the other side. It's a negative 21, so to move it, I have to add it. So it cancels out over here. I bring down the 34 in, I bring down the equals, and then I look and I say, whoa, whoa, wait a minute. Negative 21 and positive 21, what happens? They cancel out. Well, when two things cancel, it's actually what? 0. It's okay, remember to have a 0. So 34 times n, to move that 34 I have to divide, because it's multiplication to begin with. 0 divided by 34 is 0, so I think my answer is 0. So to check it, I go back and everywhere I see an n, put a 0, and I come and I look. Negative 21 minus 0 is negative 21 equals 7 times, well, 5 times 0 is 0, so this is a big old 0, right? So then I have negative 3 minus 0, so this is just negative 3. Okay with that? Negative 21 equals 7 times negative 3, which is negative 21, so n does equal 0. Okay? Moving on to the last two problems. All right, so the problem on the left, there are two sets of parentheses and lots of variables. So let's look at this. So looking at the problem, I have first to distribute to simplify the left-hand side. So 2 times negative 5 is negative 10. 2 times positive 7 is positive 14x. Then I look at the next set. I have a negative 2. So negative 2 times 8 is negative 16. Negative 2 times 6x is negative 12x equals. And then 7x and a 3x, negative 3x. Those go together, don't they? So that would just give me 4x. So look at that, think about it, make sure you're okay. Right-hand side is as simple as it gets, but when I look at that left-hand side, there's some stuff that can be combined. I have a negative 10 and a negative 16 that can go together, and I have a positive 14x and a negative 12x. So let's look at the constants first. So negative 10 and negative 16 gives me negative 26. And then a positive 14 and a negative 12 gives me positive 2x. And that equals 4x. So that is a lot more simple than it was before. But I still notice that I have two different variables, and they're on opposite sides of the equal sign. So I want to move the smaller of the two to the other. Well, what's smaller, positive 4 or positive 2? Positive 2. So I move it as a negative. We do the opposite. So negative 26, this cancels, equals 2x. 2 times x, we know the opposite of multiplication is division, so negative 13 equals x. So that is what I think my answer is. Okay? And I would encourage you to see if you can check this problem on your own, but just to save a little bit of time, this video is already going to be over 40 minutes. You will end up with 52 equals 52 if you do it correctly. Negative 13 does equal x. Okay, that is the answer. All right, so now let's move on to this one, which is actually, it looks a little bit shorter. On the left-hand side, I have parentheses that I have to do distribution for, so I bring down the 2. Positive 8 times v is positive 8v. Positive 8 times 1 is positive 8 equals 2 times v is 2v. 2 times 5 is 10. All right. So now on the right-hand side, it's as simple as it gets, but the left-hand side, I have an 8 and a 2 that can be put together. So when I go to put them together, positive 2, positive 8 is positive 10. Bring down that plus 8v. And now I have the left-hand side simplified, the right-hand side simplified. I want to bring the smallest variable to the biggest. Well, the smallest is the positive 2v, so I subtract it from both sides. So 10 equals 10 plus 6v equals 10. And now the v's are together. I just need to get the stuff away from the v, so I need to move this 10 first. It's positive, so to move it, I subtract it from both sides. So these 10's cancel. Bring down the 6v. 10 minus 10 is 0. There's that 0 again. Remember, it's okay to have a 0. I need to move the 6. It's 6 times v. So 6 divided by 6 on both sides. 6 is canceled. 0 divided by 6 is 0. So I think that my answer is 0. And I can check it. So I say 2 plus 8 times 0 plus 1 equals 2 times 0 plus 5. Well, looking in here, in the first parenthesis, 0 plus 1, we know that's 0. Excuse me, no we don't. If you know that, something's wrong. 0 plus 1 is 1. And in the second set of parentheses, 0 plus 5, we know that that is just 5. And then on the left-hand side, it's 8 times 1. We know that that is 8. And on the right-hand side, 2 times 5 is 10. Left-hand side, 2 plus 8 is 10. 10 does equal 10. So the equation b equals 0 is the correct answer.